Good morning, class. Today, we will take up Chapter 1, Engineering Mechanics General Principle. Because this is the first class, so we give an introduction to this course. Objectives. There are two objectives. One, object of study of engineering mechanics. Second, content of the course and the purpose of studying. 3, remarks on the teaching and the learning of the course. Finally, application. Chapter 1, General Principles. First section, object of study of engineering mechanics. Mechanics explores the basic law of a body in mechanical motion under the action of forces. Mechanical motion. What is mechanical motion? Mechanical motion is the change of location of a body with time. So this is a definition of mechanical motion. Mechanics includes 3 parts. A, mechanics of rigid bodies. B, mechanics of deformable bodies. C, mechanics of fluids. All the mechanics referred above belongs to classical mechanics. There are several limitations of classical mechanics. The classical mechanics only deals with one macro object. That means the object should has enough large size. Second limitation, the classical mechanics only applies for speed at the object whose speed less than that of light. Otherwise, we will apply other mechanics. For example, for those very small particles, we should use quantum mechanics. And for those whose speed is equal or larger than speed of light, should use relativistic mechanics. 2, content of the course and the purpose of studying. The course Engineering Mechanics is the primary part of classical mechanics. It limits the study on a system of particles or rigid bodies. This is an application range. We only deal with a system of particles or rigid bodies. It focuses on applying the principles of mechanics to engineering problems. So, it is both a basic course and a technical course. That means by using the theory of this course, we can already solve for practical engineering problems. Now, let's take up the contents of this course. The course can be divided into 3 parts: statics, kinematics, and kinetics. Statics study the equilibrium law of bodies under the action of forces, including free body diagram, reduction of a system of forces, and equilibrium problems. Kinematics, which only study geometric property of motion of a body, neglect the cause of motion. The final parts, kinetics, which study the relation between motion and forces for a body. Purpose of studying engineering mechanics. It is an integral component of the education of engineers whose major are based on the mechanical sciences, such as aerospace engineering, civil engineering, and mechanical engineering. A knowledge of engineering mechanics is also useful in most of other engineering subjects. Because of its character of multidisciplinary of many engineering fields, a sound training in engineering mechanics continues to be one of the most important aspects of engineering education. Section 3. Remarks on the teaching and the learning of the course. It seems that the course is easy to learn because most of the terms and the theorems are familiar to students. But students will encounter difficulties in doing homework, and a large portion of them will fail in final examination. Why? The course has different characteristics of learning. You cannot just listen to the teacher in class without thinking actively, nor only memorize the terms and the theorems by words. You should pick up information underlying the context of problem actively to form corresponding mechanical concepts and conditions. Then choose appropriate theorem to solve for the problem. Countermeasures. Your mastery of the principles of the course will be reflected in your ability to formulate and solve problems. Nearly all students require a considerable amount of practice in solving problems before they begin to develop the analytical skills that are so necessary for success in engineering. For this reason, a relatively large number of sample problems and homework problems are placed at strategic points throughout the course. Now, here is information of myself, instructor information. My name is Jane Yuan, Associate Professor. You should pay attention to the last two information. Email. This is you can use this information, this email address to contact me anytime. Homework policy. Homework will be turned in by appointment. Those who failed to turn in homework assignments over a quarter of the total times will lose the qualification to take the final examination. So please pay attention to this policy. Now, this is a grading policy. The final marks will have two parts. The homework will take 30%. Final examination will take 70% in the total mark in the final result. Now, the fourth section. Let's go to some applications of mechanics. Here is a picture of nuclear reactor. So in the designing and the construct a nuclear reactor, there are problems concerning the strength and the stability of the structure. So this is a basic issue of mechanics. Second application, this is a bridge. So there are many different kinds of structure: surface structure, column, and table. Here is a famous case, Tacoma Suspension Bridge, which crashed after 4 months of building. After newly building, after 4 hours, it collapsed. Now here is a video.
In 1940, the 4-month-old Tacoma Narrows Bridge began to sway dangerously in 40-mile-an-hour winds. Local residents called it Galloping Gertie. Ultimately, gales sweeping down the Narrows set up uncontrollable undulations, and the bridge collapsed into the water.
Okay, this is the Tacoma Bridge. Now, final examples, the express express train. In the designing of high-speed train, there are many problems concerning the vibration. So we should use our mechanics to deal with those vibration. So these are the application example. We will later on in our course, we will in detail, we will discuss those applications. So this is the end of this class. Thank you.